So for the different unit operations in the pharmaceuticals, like drying, evaporation, crystallization, distillation. So you need a application of heat. You need a application of heat energy to understand the efficiency of heat energy. To understand the efficiency in the efficiency of various kind of apparatus, which method you have to apply for what kind of purpose. So you need to understand the heat transfer. Today we are going to see heat transfer and drying. First of all, heat transfer, because if moisture is present in your powder, moisture is present in your drug, moisture is present in your crude drug, so it can affect the flow properties, physical stability, chemical stability, and a lot of problems will be there. Suppose if there is excessive moisture in the granules, so granules will not be properly flow from upper to the dye cavity. So flow properties of granules, flow properties of powder, stability. So moisture presence increases the chances of microbial growth. जहाँ पे ज़्यादा moisture होगा उसमें microbial growth ज़्यादा होगा. So there is a deterioration of your product. So if there is a excessive moisture, so that may affect the chemical stability. That may cause hydrolysis. There is more prone to oxidation, like microbial growth, contamination. So excessive moisture leads to various problems in the pharmaceutical. That's why you have to remove the excessive moisture, and for that you have to apply a heat. So it is nothing but the kind of energy which can be transmitted, which can be transferred from one system to another system. That is known as a heat transfer. I have told you what are the applications of heat transfer. So it is applicable in the drying, in the evaporation, in the distillation, in the crystallization, or various unit operations. Right? There are different mechanisms for heat transfer. So basically there are three mechanisms. Heat transfer के तीन mechanism होते हैं basically. वो mechanism एकदम short में बोलता हूँ. Because see this chapter in the book they have given lot of things, mechanism, their derivation, their laws, etc. But everything is not important for your GPAT and other exam. So what is important for GPAT exam? That will be discussed over here, right? So heat transfer, mechanism of heat transfer. So what do you mean by heat transfer? First, heat transfer means what? So flow of heat energy from one system to another system. Flow of heat energy from one system to another system is the heat transfer. हीट ट्रांसफर का मतलब क्या होता है कि इसका फ्लो हो रहा है, किसका हीट का फ्लो हो रहा है, कहाँ हो रहा है फ्लो, फ्रॉम वन सिस्टम टू अनदर सिस्टम फॉर योर यूज. That is known as heat transfer. Now heat transfer, mechanism of heat transfer. Now heat transfer is done by, it is carried out by different mechanisms. So what are the different mechanisms for? So heat transfer is carried out by three mechanisms. First one is nothing but the conduction. Second mechanism is a convection. Second mechanism is a convection, and third mechanism is radiation. So conduction, convection, and radiation. These are the three mechanisms for heat transfer. How there is a transfer of heat energy from one system to another system. So there might be a movement of individual molecules. There might be a mixing of a different portion of your material. There might be movement of heat energy. There might be conversion of radiation energy into heat energy. So these are the different mechanisms, heat transfer mechanism. For example, again heat transfer is also important for your sterilization purpose. So you might have seen, आपके घर में देखा होगा आपने कि आपके घर में जो भी अनाज होता है, जो भी प्रोडक्ट आपको बहुत पूरा साल यूज करना है, जैसे गेहूं लाए आपने मार्केट से, आप क्या करते हो, पहले उसको छत के ऊपर जाके सुखाने के लिए डालते हो कड़ी धूप में. क्यों? Because whatever energy from that sun rays or sunlight, so they are nothing but the electromagnetic radiations. From that electromagnetic radiations, they are falled on your product, whatever, for example, wheat grains. Energy is there in the form of electromagnetic radiation. So that energy is converted to heat energy. ठीक है, आप जाके बाहर अभी दोपहर में कड़ी 12-1 बजे एक पतीले में पानी लेके जाओ और रखो बाहर धूप में, पानी गर्म हो जाएगा. Why? Because the electromagnetic energy is converted into heat energy that is transmitted from the sun to the your material, that is water. आपने वाटर रखा है, वाटर हीट हो जाएगा ना, कहाँ से आएगा वो हीट आता है इलेक्ट्रोमैग्नेटिक रेडिएशन से. Electromagnetic radiation, so energy present in the electromagnetic radiation, that is converted into heat energy. Okay? That is radiation. So heat transfer mechanism. So heat transfer is important for drying, evaporation, distillation, crystallization. Heat transfer is also important for your sterilization. So you might have seen different method for sterilization. the microbiology. Dry heat. So in that you are using heat energy for the killing of microbial, okay, killing of microbes or foreign contamination. So heat transfer is also useful for the your sterilization. So what are the different methods for or mechanisms for heat transfer? So first mechanism is nothing but the पहला mechanism होता है conduction. ठीक है, आपको mechanism के ऊपर क्वेश्चन आते हैं. So what is conduction? कहाँ पे conduct होता है? तो conduction is nothing but the flow of heat. It is the flow of heat or transfer of heat by momentum of individual molecules or atoms. तो इसमें क्या होता है कि जो भी surface होगा, for example, say for example metallic surface. So in the metal surface, the heat transfer through a metal surface occurs via movement of individual molecules, via movement of individual atoms. So that kind of transfer is known as a conduction. So transfer of heat through a metal wall. That is the example. Okay? Flow of heat through a metal wall of boiler. Suppose आपका इंडस्ट्री है, आपके इंडस्ट्री में बॉयलर है बड़ा. So बॉयलर को आप क्या करते हो, नीचे से लकड़ियाँ डालते हो, लकड़ियाँ जलाते हो, तब ये आपके बॉयलर का पानी गर्म होता है. लकड़ियाँ डालते हो या फिर आप यू यूज कोल, आप कोयला यूज कर सकते हो, आप लकड़ियाँ यूज करते हो या फिर आप इलेक्ट्रिसिटी यूज करते हो. तो मोस्ट cheapest form of heat is nothing but the electricity, or conduction means what? Transfer of or flow of energy, that is heat energy, because of the movement of individual atoms or molecules, okay, without mixing. Remember, without mixing. So movement of individual atoms or molecules without mixing is nothing but the conduction. So example is nothing but the flow of heat through metal wall. जो metal wall होता है आपका बॉयलर का, या फिर कोई भी आप एग्जांपल ले लो, आयरन का metal wall है. So heat transfer through a metal wall occurs via conduction. So conduction कहाँ से होता है? So conduction is the mechanism of heat transfer for solids only. Solids में क्या होता है? Mechanism कौन सा है heat transfer का? Conduction. So flow of heat by transfer of momentum of individual molecules or atoms without mixing is nothing but the conduction. Now this is applicable only for solids. ये solids के लिए applicable है. Example is nothing but the heat flow through metal wall of boiler, right? That is a conduction. Second mechanism is nothing but the, okay, second mechanism is convection. Third mechanism is radiation. So under the conduction only, so heat transfer by conduction, there is a one law in the heat transfer by conduction. इसमें एक लॉ आता है known as a Fourier's law. ठीक है, ये आपको याद रखना पड़ेगा. So in the conduction heat transfer by conduction mechanism, that is transfer of heat through metal wall of boiler or transfer of heat through any kind of metal wall. So that is involves the conduction mechanism. Now that is governed by Fourier's law. Okay, so conduction of heat through metal wall. क्या है Fourier's law? Conduction of heat through metal wall. Heat flows through uniform material. Okay, heat flow through uniform material is proportional to. Proportional मतलब यहाँ पे directly proportional. Heat flows through uniform material is proportional to the area and temperature drop across the surface of metal, and inversely proportional to the length of path of flow. Path of. Okay, I will explain this law you again. आपको याद रखना है, इसके ऊपर क्वेश्चन आता है Fourier's law. So what is Fourier's law? It is nothing but this law states that heat transfer by conduction through a metal wall, that is based upon what? It is based upon, okay, so heat transfer through a metal wall. Okay, so Fourier's law states that heat flow through uniform material which is proportional to the area of that metal and temperature drop across the metal. Temperature drop means क्या है? मान लीजिए कि आपका पास एक मेटल है, यहाँ ये जो एक पॉइंट है यहाँ पे ज़्यादा टेम्परेचर है, ये जो पॉइंट है उसके यहाँ पे कम टेम्परेचर है. सो हीट विल फ्लो फ्रॉम हायर टू द लोअर, दैट इज known as a heat gradient. So there should be heat gradient. Okay, so heat flow through the uniform material is proportional to the area of metal, and then temperature drop. Temperature drop means what? Difference in the temperature at two surface. Difference in the temperature at two surface. Temperature drop means what? Difference in the temperature at the two surface. So heat flow through a metal wall that depends on, or that is proportional to the area of that metal, temperature drop across the metal, okay, and inversely proportional to the length of that, inversely proportional to the path flow, or okay, length of that flow. तो बेसिकली फ्रेयर्स लॉ क्या कहता है कि हीट ट्रांसफर जो हो रहा है मेटल से वो किसके ऊपर डिपेंड है. सो हीट फ्लो थ्रू द यूनिफॉर्म मटेरियल इज प्रोपोर्शनल टू, वो डायरेक्टली प्रोपोर्शनल है किससे, जो एरिया है मेटल का, एंड जहाँ पे टेम्परेचर कोएफिशिएंट कितना है, टेम्परेचर ग्रेडियंट कितना है, उसके ऊपर डायरेक्टली प्रोपोर्शनल. सो हीट फ्लो थ्रू ए यूनिफॉर्म मेटल is proportional to the area and temperature drop or temperature gradient or temperature coefficient across the metal, and it is inversely proportional to the length of path of flow. Okay, so again it states that nothing but the time and rate of heat transfer through a material is proportional to the negative gradient of temperature. मतलब जितना ज़्यादा टेम्परेचर ग्रेडियंट रहेगा उतना ज़्यादा हीट फ्लो ज़्यादा रहेगा. सपोज दिस इज वन मेटल, at this point there is a higher temperature. यहाँ पे क्या है, हायर टेम्परेचर मतलब हीट ज़्यादा है यहाँ, यहाँ पे क्या है, हीट कम है. सो हीट विल फ्लो क्विकली फ्रॉम हायर टू द लोअर. सो हायर टू लोअर, if there is a same temperature at this end and this end also, that is known as equilibrium. अगर दोनों एंड में सेम टेम्परेचर है तो उसको बोलेंगे इक्विलिब्रियम. एक एंड पे ज़्यादा टेम्परेचर है, एक एंड पे कम टेम्परेचर है. सो हीट विल फ्लो फ्रॉम higher temperature to the lower temperature, okay, more quickly. Fourier's law states same thing. The time rate of heat transfer through a material is proportional to the negative gradient. जितना ज़्यादा डिफरेंस रहेगा उतना ज़्यादा हीट जल्दी फ्लो रहेगा. मतलब हायर टेम्परेचर लोअर टेम्परेचर में कितना ज़्यादा डिफरेंस है, बहुत कम डिफरेंस है तो वहाँ पे हीट फ्लो उसका रेट जो है कम रहेगा. जहाँ पे जैसे यहाँ एक साइड पे आपका टेम्परेचर है 10 डिग्री सेल्सियस और एक एंड पे टेम्परेचर आपका 90 डिग्री सेल्सियस, तो वहाँ पे एकदम फास्ट हो जाएगा फ्लो ऑफ. सो रेट ऑफ हीट ट्रांसफर दैट विल बी हायर if there is a higher gradient, if there is a higher negative gradient of the temperature and to the surface area. Okay, so that is the Fourier's law. It is given by this formula: Q is equal to minus K, Q is equal to minus K into A divided by dt by dx. This is the formula for heat transfer by Fourier's law. Actually ये formula आपको नहीं पूछेगा भाई, but you should know. So Q is equal to minus K into A dt by dx, minus k dt by dx. Okay, what is q? Q is nothing but the flow of heat or flow rate of heat, flow rate of heat by conduction. So heat flow by conduction. W, okay, that is उसका यूनिट होता है W. What is k? K is nothing but the thermal conductivity of body material. So every material, हर एक material का क्या है, so material का thermal conductivity है. देखो for example आपने कोई भी मटेरियल एक बाहर रख दिया, उसके ऊपर सनलाइट ए मटेरियल विल एब्सॉर्ब आइदर दैट लाइट और आइदर द मटेरियल विल रिफ्लेक्ट दैट लाइट. ओके, सो द अमाउंट ऑफ रिफ्लेक्टेड लाइट इज नोन एज द रिफ्लेक्टिविटी ऑफ दैट मटेरियल एंड अमाउंट ऑफ एब्सॉर्ब्ड लाइट that is known as the absorptivity of that. So Q is nothing but the heat flow rate, K is nothing but the thermal conductivity. Thermal conductivity मतलब वो मेटल या फिर वो आइटम कितना हीट को कैरी करता है, दैट इज थर्मल कंडक्टिविटी. ओके, सो K is the thermal conductivity of body, then A is nothing but the cross sectional area of your that surface normal to the direction of heat flow, and dx by dt by dx is nothing but the temperature drop or temperature gradient. ठीक है, so ये फॉर्मूला है. इसका डेरिवेशन, if you want to see the derivation how, so you have to go in the read and you have to go. So derivation, it is not a part for GPAT lecture. So what is important from the mechanism of heat transfer? Conduction is the mechanism of heat transfer for metals. Okay, question इसके ऊपर GPAT 2021 में. Fourier's law governs is the law behind heat transfer by conduction. So it states that heat flow through uniform material is proportional to the area of that material or area of that metal and temperature drop across the metal, and inversely proportional to the length of that metal, right? Okay, so Q is equal to minus K A dt by dx. Q is nothing but the rate of heat flow. Okay, K is nothing but the thermal conductivity of that material. A is the cross sectional area of material, and dt by dx is nothing but the temperature gradient or temperature. Now second mechanism for heat transfer is nothing but the convection. Convection है, not a convection. Convection नहीं होता था, यहाँ पे ई चाहिए, convection. Convection मतलब गुना. So convection is nothing but the again another mechanism for heat transfer. When heat flow is achieved by actual mixing of warmer portion with the cooler portion in the same material, that is known as a convection. इसका मतलब क्या होता है? Simple. You might have seen the water heaters. आपने water heaters देखा होगा, ठीक है? आप सर्दी में पानी गर्म करने के लिए वाटर हीटर देखते हैं, तो क्या होता है, आपने जब जैसे ही पानी गर्म करने के लिए रखा तो इनिशियली क्या होता है, ऊपर का पानी आपको गर्म लगता है और आपको तब पता चलता है कि नीचे पानी ठंडा है। कब? जब आप बाल्टी उठा के नहाने के लिए जाते हो, ऊपर का पानी गर्म है, नीचे का पानी क्या है? ठंडा है। बिकॉज क्या होता है कि पहले पानी जो था आपका नॉर्मल वाटर, सो इट हैज द सेम डेंसिटी, राइट? उसका जो डेंसिटी था सेम था, बट ड्यूरिंग द वाटर हीटिंग, आपने जब वाटर हीटर डाला, उसमें हीटिंग चालू किया, जो पोर्शन है जो मेन हीटर के कांटेक्ट में आता है, वो पोर्शन क्या होता है? हीट हो जाता है, उसका डेंसिटी कम हो जाता है, वो ऊपर आ जाता है, और जिसका डेंसिटी ज़्यादा है वो नीचे जाता है। ओके, देयर इज अ मूवमेंट ऑफ flow of that material, there is a mixing. Okay? Heat flow which is achieved by actual mixing of warmer portion with the cooler portion of the same material, that is known as a convection. Now what is the example of this type of mechanism? So example is nothing but the heating of water with the water heaters. So heating of water with the water heaters involves the convection heat transfer. So transfer of heat through metal, that is the mechanism is nothing but the conduction, transfer or heat flow through a liquid or fluid is nothing but the it is the mechanism in all is the convection. Okay, convection. तो मेटल में जो हीट ट्रांसफर होता है उसको कंडक्शन बोलते हैं. ओके, सॉलिड, सो कंडक्शन इज मोस्टली एप्लीकेबल फॉर द सॉलिड. ओके, दैट इज द कंडक्शन, एंड कन्वेक्शन इज एप्लीकेबल टू द लिक्विड्स और फ्लूइड्स. राइट, रिमेंबर. ठीक है, सॉलिड्स के लिए आपका कंडक्शन आएगा, लिक्विड्स के लिए आपका और फ्लूइड्स के लिए आपका कन्वेक्शन आएगा. सो कन्वेक्शन मींस flow of fluid or flow of heat which is achieved by actual mixing of warmer portion into the cooler portion of same material, that is nothing but the convection. Now example is heating of water with the water heaters, right? Convection heat transfer is the transfer of energy. Okay, transport due to bulk of fluid motion. तो ट्रांसफर ऑफ एनर्जी क्यों हो रहा है? ड्यू टू बल्क ऑफ मोशन, बल्क ऑफ फ्लूइड मोशन. तो जो वार्मर पोर्शन था ऊपर नीचे का, वो ऊपर आ गया और ऐसा मिक्सिंग हो रहा है. तो एक्चुअल मिक्सिंग मटेरियल हैविंग हायर एनर्जी with the material having lower energy. Or convection heat transfer is nothing but the energy transfer due to bulk of motion. This type of heat transfer is through gases and liquid. This type of heat transfer is through gases and liquid form. Solid boundary result between warmer portion और टू डिफरेंट पोर्शन. जहाँ पे वाटर में क्या होता है, दो पोर्शन होता है, वार्मर पोर्शन, गर्म वाला पोर्शन एंड ठंडा वाला पोर्शन. सो देयर इज अ बाउंड्री बिटवीन दैट टू. ओके, देयर इज अ सॉलिड बाउंड्री रिजल्ट फ्रॉम द एंड फ्लूइड ऑफ मोशन along with the. So convection heat transfer is because of the actual movement or actual mixing or motion of the two different portion of the same liquid, known as a convection. So heat transfer through a metal, conduction, heat transfer to a liquid or fluid is the mechanism is a convection. So mechanism of heat transfer in the metals, conduction. Mechanism of heat transfer in the fluids and liquids, convection. Remember. Now this convection is given by Newton's law. इसके ऊपर कौन सा लॉ है? न्यूटन्स लॉ. Newton's determine that transfer of heat per unit area. Okay, transfer of heat per unit area. So heat per unit area, transfer of heat per unit area is proportional to the fluid solid temperature difference. Temperature difference कितना है fluid and solid में? So heat transfer उसके ऊपर depend है. ठीक है? So heat transfer by convection depends on the, okay, that is directly proportional to the temperature difference between fluid and solid. Heat transfer per unit area is proportional to the temperature difference of fluid and solid. That is given by Newton. So conduction में क्या था? Fourier's law था. यहाँ पे क्या है? Newton है. Newton's law. You have to remember. Temperature difference usually occurs across a thin layer of fluid adjacent to the solid surface. Fluid मतलब क्या है? Solid. यहाँ पे fluid मतलब क्या है? यहाँ पे दो टाइप. Fluid मतलब either water air or water or solid. The temperature difference usually occurs across the thin layer of fluid adjacent to the solid surface. मान लीजिए कि आपके पास में कोई सस्पेंशन है, उसमें सॉलिड पार्टिकल भी रहेगा और लिक्विड भी रहेगा, और सॉलिड और लिक्विड के बीच में क्या रहेगा? एक छोटा सा बाउंड्री रहेगा. So temperature difference usually occurs at that thin layer of fluid adjacent to the solid surface. That is known as a boundary layer. That is known as a boundary layer. That is called as the boundary layer. The constant proportionality is called as a heat transfer coefficient. Heat transfer per unit area Q by A is directly proportional to the Ts minus Tf. Ts क्या है? Temperature of solid. Tf क्या है? Temperature of fluid. As per the Newton, heat transfer by convection, heat transfer per unit area is proportional to the fluid solid temperature difference. Okay, so Q divided by A is directly proportional to the Ts minus Tf. Ts क्या है? Temperature of solid, temperature of Tf is temperature of fluid. अगर उसका डेरिवेशन करेंगे तो आपको यहाँ पे हीट ट्रांसफर कोएफिशिएंट ये लेना पड़ेगा. तो बाद में डेरिवेशन वगैरह वो जो है बाद में बुक में देख लेना. दैट इज वेरी कॉम्प्लिकेटेड, तो आपको जीपैट में आने भी नहीं वाला. जीपैट में क्वेश्चन कैसा है वो मैं आपको बोलूंगा. Q divided by A is equal to H into Ts minus Tf. That is the equation. So convection के different types होते हैं. There are different types of convection. So heat transfer by convection, it is either by natural convection due to difference in the density. जैसे वाटर में होता है, हीट से मटेरियल वाटर को हीट करेंगे, उसका डेंसिटी कम होता है, वो सरफेस के ऊपर आता है. जिसका डेंसिटी ज़्यादा है वो बॉटम में रहेगा. So that is known as a natural convection. Okay, so movement of warmer portion and cooler portion due to a difference in the density known as a natural convection. Now there is another known as a forced convection. So in the forced convection you have to apply, okay. So in the natural convection क्या हो रहा है कि mixing कैसे हो रहा है? Because of the difference in the density. That is known as a natural convection. Now forced convection means what? So you have to force, you have to push the liquid, two different liquids, warmer and cooler, by using pumps or by using fans. You can use agitation. आप उसको mix कर रहे हो, agitate कर रहे हो. So that is known as a forced convection. So there are two types of convection: natural convection and forced convection. What is boiling? Boiling is change in the phase from liquid to vapor. Boiling किसको कहते हैं? Boiling, water boil करते हो तो मतलब क्या है? Water liquid to vapor. That is boiling. Condensation मतलब क्या है? अभी जहाँ पे opposite to the boiling. Boiling मतलब क्या है? So conversion of liquid into vapor by application of heat. That is a boiling. Now what is meant by condensation? Conversion of vapor into liquid. That is known as condensation. The condensation means conversion of vapors into liquids. Boiling means conversion of liquid into vapors. Both are the opposite phenomena. Boiling and condensation. Heat transfer were important points. So flow of heat, that is the flow of heat energy into मतलब into or out of system. मतलब flow of heat into the system or out of the system, which is very important for your pharmaceutical industry. For industrial scale, cheap source of heat is nothing but the steam and electrical power. तो इंडस्ट्री में मैक्सिमम हीट के लिए क्या यूज किया जाता है? स्टीम यूज किया जाता है. स्टीम, वाटर वेपर, heated evaporated water vapor. It is steam, heated steam, and electrical power. So it is very important in the different kind of unit operations I have told you, like evaporation, distillation, drying, crystallization, and sterilization. Thermal conductivity. What is meant by thermal conductivity? So it is nothing but the reciprocal of thermal resistance. Thermal conductivity is nothing but the reciprocal of thermal resistance. Coefficient of thermal conductivity. यहाँ पे coefficient है. Coefficient of thermal conductivity is nothing but the amount of heat that flows across the unit surface area in the unit time. एक unit surface area में unit time में कितना heat flow हो रहा है उसको क्या बोलेंगे? Coefficient of. So coefficient of thermal conductivity is nothing but the amount of heat that flows across the unit surface area in a unit time. when temperature drop is a unit. टेम्परेचर ड्रॉप भी क्या होना चाहिए, कांस्टेंट. सो कोएफिशिएंट ऑफ थर्मल कंडक्टिविटी, थर्मल कंडक्टिविटी इज डिनोटेड बाय K. Now it is a reciprocal of thermal resistance. Now coefficient of thermal conductivity is nothing but the amount of heat that flows across the unit surface area in the unit time when temperature drop is a unit. So thermal conductivity of solid is higher than liquids and fluids. सॉलिड का थर्मल कंडक्टिविटी ज़्यादा होता है, सॉलिड ज़्यादा देर तक गर्म होता है, ज़्यादा देर तक हीट एनर्जी वो कंडक्ट कर सकता है. Solid will have a higher conductivity that of the liquid, and solids will have a higher conductivity as compared to liquids and fluids. Okay, you have to remember. Now there are different types of convection. I have told you. So forced convection and natural convection. Now, in case of forced convection, sometimes what happens due to deposition of films. तो जो भी आप जैसे मान लीजिए फोर्स कन्वेक्शन, हीट ट्रांसफर कर रहे हो, कैसे करेंगे आप हीट ट्रांसफर? मान लीजिए कि आपको जो बायोलॉजिकल एक्सट्रैक्ट है उसको ड्राई करना है, ठीक है, यू हैव टू कॉन्संट्रेट द बायोलॉजिकल एक्सट्रैक्ट. सो यू कैन नॉट अप्लाई डायरेक्ट हीट, आप डायरेक्ट हीट नहीं अप्लाई कर सकते, नहीं तो वो डिजनरेशन हो जाएगा, डिग्रेड हो जाएगा. सो यू हैव टू अप्लाई हीट बाय यूजिंग स्टीम. तो आप उसमें एक जैकेट में स्टीम पास करते हो and you use pumping steam. So in forced convection, so there is a film deposit on the walls of metal. जो मेटल का ट्यूबिंग होता है जिसमें आप स्टीम पास कर रहे हो, ठीक है, उस ट्यूब में क्या होता है, स्टीम मतलब क्या, वाटर वेपर्स, उसमें कभी कभी क्या होता है, सॉलिड डिपोजिट हो जाता है, सॉल्ट्स. सो दैट डिपोजिट्स, ओके, they will decrease the heat transfer. In the forced convection, film deposit on the wall, they offers resistance to the heat transfer. And okay, film coefficient क्या होता है, film coefficient is nothing but this film coefficient, quantity of film coefficient is the quantity of heat flowing through unit area of the film for unit drop in the temperature. So film coefficient क्या होता है, थर्मल कंडक्टिविटी देखा, थर्मल कंडक्टिविटी coefficient of thermal conductivity क्या है. So coefficient of thermal conductivity is nothing but the amount of heat that flows across the unit surface area. एक यूनिट का सरफेस एरिया है, उसमें कितना हीट फ्लो हो रहा है पर यूनिट टाइम when temperature drop is per unit or constant. That is a thermal coefficient of thermal conductivity. Now what happens in the forced circulation or forced convection? So film deposits, there is a deposition of films on the walls of tubing. So that decreases the heat transfer. Now film coefficient is the term that is nothing but the quantity of heat flowing through a unit area of the film for unit drop in the temperature. That is a film coefficient. Okay? ये definition आपको कभी पूछ देंगे. Now amount of radiation falling on the body. Now third we will see radiation transfer. So amount of radiation falling on the body. Body मतलब कुछ भी मटेरियल ले लो, जैसे मेटल होगा, आपका ग्लास होगा. So amount of radiation falling on the body which are reflected, the reflected fraction is known as a reflectivity. So मान लीजिए there is some body in the sunlight, say for example metal, a piece of metal, उसके ऊपर जब sunlight गिरता है, so amount of radiation falling on the body, okay, which are reflected. अगर वहाँ पे मेटल की जगह ग्लास होगा तो वो क्या करेगा, रिफ्लेक्ट करेगा. So suppose that glass is there in a sunlight, so it will reflect the radiation. So amount of radiation falling on the body and reflected radiation or reflected fraction of that radiation, reflectivity of that material. The fraction of rays which are reflected by a material from the rays falling on the material, that is known as reflectivity. And amount of radiation which is being absorbed is known as absorptivity. जैसे metal, suppose कोई metal है वो रखा आपने sunlight में, so what will happen, metal will absorb the radiation and will convert radiation energy into heat energy, right? Now if अगर आपने glass रख दिया, so what will glass do, it will reflect the light. So fraction of light or rays reflected known as a reflectivity, and whatever fraction of rays which are falling on material, that is absorbed, known as a absorptivity. Now black body मतलब क्या, what I mean by black body? So black body is nothing but the body or material that radiates a maximum possible amount of energy at a given temperature. So हर एक solid material जो होता है, every solid material इट कैन रेडिएट द एनर्जी, वो इमिट कर सकता है एनर्जी, एवरी सॉलिड मटेरियल, बट अप टू अ डिफरेंट रेट्स। तो एक मटेरियल अलग से कुछ क्वांटिटी में इमिट कर सकता है, एक मटेरियल अलग से क्वांटिटी, ओके। बट दिस ब्लैक बॉडी सो डिजाइंड रेडिएट्स मैक्सिमम पॉसिबल अमाउंट ऑफ एनर्जी एट अ गिवन टेम्परेचर। ब्लैक बॉडी मतलब ये सबसे ज़्यादा इमिट करने वाला होता है, इट विल रेडिएट मैक्सिमम पॉसिबल अमाउंट ऑफ एनर्जी एट अ गिवन टेम्परेचर। All solids can radiate energy at absolute zero temperature, but not at a same rate, at a different. Black body, ठीक है, क्वेश्चन इसके ऊपर आता है, तो बोल्ड करना भूल गया, रेडिएशन एब्सॉर्ब करेगा, लेकिन हीट एनर्जी इमिट करेगा। इट विल एब्सॉर्ब द रेडिएशन, बट इट विल इमिट मैक्सिमम अमाउंट ऑफ एनर्जी इन द फॉर्म ऑफ हीट at a given temperature. So that's why it is known as a black body. बाकी जो सॉलिड, जैसे बाकी जो सॉलिड है उसको भी अपन बॉडी बोलेंगे। सो बाकी सॉलिड्स क्या है, वो भी एब्सॉर्ब करते हैं रेडिएशन, बट दे विल आल्सो रेडिएट एनर्जी, वो एनर्जी भी रिलीज करेंगे, बट एट अ डिफरेंट रेट्स, हर एक मटेरियल अलग रेट से। बट ब्लैक बॉडी क्या करता है, सो इट विल रेडिएट द मैक्सिमम पॉसिबल अमाउंट ऑफ एनर्जी एट अ गिवन टेम्परेचर, दैट्स व्हाई इट नोन एज द ब्लैक बॉडी। नाउ देयर आर डिफरेंट अनदर टर्म नोन एज द ग्रे बॉडी। ग्रे बॉडी क्या होता है, इट इज अगेन a body whose absorptivity is a constant at all wavelength of radiation at a given temperature। इसका absorptivity क्या है, constant होता है at a given all wavelength at a given temperature। तो ब्लैक बॉडी और ग्रे बॉडी में डिफरेंस क्या है, इंपॉर्टेंट है, क्वेश्चन इसके ऊपर आता है। आपको आइडियली आपको एक बार पढ़ना चाहिए वो पूरा चैप्टर, ठीक है, फ्रॉम द रेफरेंस बुक, बट यहाँ पे इंपॉर्टेंट इसके ऊपर क्वेश्चन आता है। ब्लैक बॉडी मीन्स व्हाट, so it is a material or it is a body that radiate maximum amount of energy at a given temperature। ये रेडिएशन एब्सॉर्ब करेगा एंड एनर्जी रिलीज करेगा। ग्रे बॉडी किसको बोलते हैं, सो बॉडी विच whose absorptivity is a constant at all wavelength of radiation at a given temperature, right? Heat exchanger मतलब क्या, what is meant by heat exchanger? So any kind of device that is used for the transfer of heat from one fluid to the another fluid through a metal wall। तो हीट एक्सचेंजर किसको बोलते हैं, सो हीट एक्सचेंजर्स। हीट ट्रांसफर में आपको क्यों पढ़ना है, अपन ने देखा है कन्वेक्शन, कंडक्शन एंड कन्वेक्शन, बट कैसे ट्रांसफर करेंगे हीट, आपको अगर कुछ इवापोरेट करना है तो उसको हीट ट्रांसफर करना पड़ेगा, कैसे करेंगे, सो हीट एक्सचेंजर्स, सो दैट इज द डिवाइस फॉर ट्रांसफर ऑफ फ्रॉम वन फ्लूइड टू अनदर फ्लूइड। फॉर एग्जांपल से फॉर एग्जांपल आपको ये ऑपरेट करना है, आपका स्लरी, इसका स्लरी पैंक्रियास का एक्सट्रैक्ट निकाला है, उसका कॉन्सेंट्रेशन करना है, you have to make concentrated slurry of your pancreatic extract, so you have to apply the heat। if you apply direct heat, so your product will be lost, आपको उसका useless बनेगा, so you have to apply heat in the form of steam, so in the form of fluid, well, so device used to transfer the heat from one fluid to the another fluid through a metal valve known as a heat exchanger। Now second, heat interchanger। heat exchanger किस में अप्लाई करते हैं, heat exchanger is applicable for transfer of heat energy from one fluid to another fluid or liquid। तो heat exchanger क्या है, so it will transmit heat energy from one fluid to the another fluid or liquid। now heat interchanger क्या है, heat interchanger is the device used to transfer the heat from one liquid to another liquid or from one gas to another gas molecule through a metal wall। इसमें डिफरेंस क्या है, हीट एक्सचेंजर मतलब क्या, इसमें क्या रहेगा, एक जो फ्लूइड है वो ज़्यादा हॉट रहेगा, ट्रांसफर ऑफ हीट एनर्जी फ्रॉम वन फ्लूइड विच इज अ हॉट, one fluid which is a hot, say for example hot gas or steam, to the another fluid which is a, जिसको आपको ये ऑपरेशन करना है उसको ये ट्रांसफर कर देगा, दैट इज अ हीट एक्सचेंजर। नाउ व्हाट डू यू मीन बाय हीट, व्हाट डू यू मीन बाय हीट इंटरचेंजर, व्हाट डू यू मीन बाय हीट इंटरचेंजर, डिवाइस यूज्ड टू ट्रांसफर द हीट फ्रॉम वन लिक्विड टू अनदर लिक्विड ओनली, मतलब जो ऑलरेडी हॉट है वो दूसरे लिक्विड को हॉट करेगा और गैस, so device used to transfer heat from one liquid to another liquid or one gas to another gas। but heat exchanger क्या है, it can transmit a heat one fluid में भी इधर, ठीक है, fluid में steam भी आता है या फिर hot air भी आता है या फिर gas भी आता है, so fluid to another liquid। Heat exchangers will transmit heat energy liquid from the fluid, hot air or hot gas or steam. But heat exchanger में क्या होता है? Hot liquid will transfer energy to the another liquid. Hot gas will transfer energy to the another hot gas or another cold gas. Okay? So gas to gas, liquid to liquid known as a heat interchanger. Fluid to liquid known as a heat exchanger. Okay? Now radiation heat transfer by radiation. So याद रखो आपका what are the different mechanism for heat transfer? Conduction, convection and radiation. So conduction through metal wall, convection in the liquids or fluids, radiation heat flows through a space by means of electromagnetic waves. Such energy is known as a radiation energy. So whatever sunlight you are getting, आपको sunlight में खड़े रहो आप गर्म हो जाओगे. Why? Because that electromagnetic radiation or electromagnetic waves that has some energy. And when they fall on your body will convert that energy into heat energy. So heat flows through a space by means of electromagnetic waves. Such energy is transfer is known as a energy transfer by radiation. So radiation heat transfer is energy transfer due to emission of electromagnetic waves or photons from the surface of surface or volume. The radiation does not require a heat transfer medium. It can occur in a vacuum also. रेडिएशन हीट ट्रांसफर क्या है कि ये वैक्यूम में भी हो सकता है, इसमें कोई मीडियम नहीं लगेगा. जैसे आपको कंडक्शन के लिए आपको सॉलिड मीडियम लगता है, कन्वेक्शन के लिए लिक्विड लगता है या फिर फ्लूइड लगता है, बट रेडिएशन के लिए मीडियम नहीं लगता है. रेडिएशन हीट एनर्जी इज द एनर्जी ट्रांसफर ड्यू टू emission of electromagnetic waves or photons from the surface or from the volume of body. The radiation does not require heat transfer medium. It can occur in the vacuum also. There is one law behind this. There is one law behind this known as a Stefan-Boltzmann law. जो हीट ट्रांसफर बाय कंडक्शन था उसमें फूरियर्स लॉ आता है, याद रखो. जो हीट ट्रांसफर बाय कन्वेक्शन था उसमें न्यूटन्स लॉ आता है, याद रखो, नाम ही याद रखो. और हीट ट्रांसफर बाय रेडिएशन उसमें कौन सा लॉ होता है? स्टीफन बोल्ट्जमैन. So heat transfer by radiation is proportional to the fourth power of absolute temperature of heat transfer by radiation is proportional to the fourth power of absolute temperature of material. The proportionality constant is nothing but the Stefan Boltzmann constant, and it is nothing but the 5.67 into 10 raised to minus 8. उसका यूनिट होता है watt meters square k raised to 4. Heat transfer also depends on the emissivity of material. Material का emissivity कितना है, वो कितना emit करता है radiation. Now again you can see here summary, the mechanism, description, example and related laws. So conduction, heat transfer by conduction. So heat flow by momentum of individual molecules or atom. Example is nothing but the heat transfer through a metal wall of boiler. Now this kind of mechanism of heat transfer, conduction, is only restricted to solids and fluids with a limited movement. There should be temperature gradient. For the effective heat transfer, there should be temperature gradient. Temperature gradient should be the transfer of heat from hot to cold surface. There is a peak transfer. Now, इसमें क्या है? There is a Fourier's law. So, conduction of heat through a metal wall. Fourier's law. याद रखो. Heat flows through a uniform material which is proportional to the area temperature drop across the metal surface and inversely proportional to the path length of flow. Law of Fourier's law. Second time. Again mechanism क्या है? दूसरा convection. So second mechanism of heat transfer is a convection. Heat flow by actual mixing of warmer portion to the cooler portion in the same material. जैसे water heater होता है आपका. So heat transfer by actual mixing of warmer portion to the cooler portion in the same material. For example, heating of water by water heaters. So it is only this mechanism is only restricted to the flow of heat in the fluids. Fluids मतलब क्या? Liquid भी हो सकता है, gases भी हो सकता है. Liquid plus air, that is also fluid. Gas plus liquid is a fluid again. Convection is the heat transfer mechanism for fluids, that is either liquid and gases both. Conduction is the mechanism for हीट ट्रांसफर थ्रू ए मेटल या थ्रू, तो उसमें आपका न्यूटन्स लॉ है, ओके। उसमें डिफरेंट टाइप आता है, फोर्स कन्वेक्शन, मिक्सिंग ऑफ mixing or transfer of heat by mixing of two portion by using external agitation or pumping or stirring. Then natural convection होता है, इसमें mixing of content due to setup in the system, जो already setup है उसकी वजह से due to movement of two different portion to difference in density से water में होता है, that is a convection. Now third one is nothing but the radiation. So radiation heat transfer mechanism. So heat flow through by means of electromagnetic radiation or electromagnetic waves through a space. For example, solar water heater. सोलर वाटर हीटर तो क्या करेगा वो, आपको एक पैनल लगाना पड़ता है, रेज सोलर रेज विल बी fall on that panel will convert heat energy, so that will convert electromagnetic energy to heat. Cookers water sorry, then solar water cookers, सोलर कुकर्स, माइक्रोवेव ओवन में भी देखो आप क्या होता है, उसमें आप इलेक्ट्रिकल एनर्जी है दैट इज कन्वर्टेड इनटू रेडिएशन एनर्जी एंड दैट विल कन्वर्ट इनटू हीट एनर्जी. सोनिकेटर बाथ रेडिएशन एनर्जी इज कन्वर्टेड इनटू, तो इसका लॉ कौन सा है, स्टीफन बोल्ट्जमैन लॉ. यूज द अमाउंट ऑफ रेडिएशन which is emitted by black body. We will see thermal conductivities of some material. इसके ऊपर क्वेश्चन आ चुका है, ऐसा क्वेश्चन था, following material has a highest thermal conductivity. क्वेश्चन क्या था, following material has a highest, जैसे इसमें है, इसका है देखो material and thermal conductivity, right? First one is nothing but the copper. Copper has a highest thermal conductivity 379 watt mk, watt per mk, इसका यूनिट होता है W. कॉपर एज हाईएस्ट थर्मल कंडक्टिविटी, आंसर भी कॉपर ही था 379. उसके बाद में आता है स्टील, स्टील हैज अ कंडक्टिविटी 43 ओनली. देन एल्यूमिनियम हैज अ थर्मल कंडक्टिविटी ऑफ 24.2. देन स्टेनलेस स्टील हैज अ थर्मल कंडक्टिविटी ऑफ 17. ग्लास उसके बाद में 1, वाटर का आता है 0.62. आपको यहाँ पे इतना याद रखना है कि हाईएस्ट थर्मल कंडक्टिविटी किसका होता है, कॉपर का. कॉपर हैज अ हाईएस्ट थर्मल कंडक्टिविटी. We have to remember this. Question आ चुका है. Copper has a higher thermal conductivity 379, steel 43, aluminum 24, stainless steel 17, glass 1 and water 0.62. बुक में और एक एग्जांपल दिया था,